let's take a look at the first activity. So in the first activity, it's really just kind of a fun activity to get you comfortable looking at graphs and reading the information. So our goal is to pick the graph that best represents the situation. So in one, it says a train pulls into a station and lets off its passengers. So as the train pulls in, you would expect it to slow to a stop. If the speed stopped too abruptly, that would be uncomfortable for the passengers. So I would say we can get rid of this one because that would be an immediate stop. Um, and this one, we speed up, slow down, which doesn't make a whole lot of sense. So of these, I would say that our best choice as far as pulling into the station to let off passengers would be this one. I would really like to see it level off a little bit at the bottom at 0. Um, so that we knew that the train was stopped for a while, so we don't have passengers jumping off a moving train. On 2, we've got a man takes a ride on a Ferris wheel. So first one, this was is distance from ground versus time elapsed. A little different graph. Um, Clearly, distance from ground with time elapsed. This one is very problematic for the rider through that section because the rider would have to be in 3 different places at the same time. All right, so that first one is definitely out. Now, on a Ferris wheel, you'd expect the rider to move up in height from a starting point and then slowly go around in a circle. So you'd expect them to go to the same max height and then back down to the same max bottom and keep looping like that. All right, B does do that behavior. C, the Ferris wheel is getting smaller and smaller and smaller for the top height of the Ferris wheel, so that's out. And in D, we have that same issue where the person is in multiple places at the same time right there. So B would be our best choice. If I take a look at number 3, 3 says a woman climbs a hill at a steady pace, right, and then starts to run down the other side. So climbs the hill at a steady pace, we'd expect speed to stay the same, and then runs down one side, we'd expect the speed to increase as they move down that side. So when I look at this, the only graph that really follows that is A, where we have a constant speed moving across this first section, and then it speeds up as we go through. All right, number 4, we've got a child swings on a swing. All right, so if they swing on a swing, we would expect them to drop back down to that lowest position, increase back to the lowest position, increase height a little bit more, back to the 0, and so on. All right, so when I look at this, probably this one, A, looks to be the best to me as they're speeding up. So the child is speeding up as they swing, so they're moving to a little bit higher max heights each time on the forward swing, and then a little bit higher on the backward swing, and then a little bit higher on the forward swing. This next one, basically as they go through, they go up, but they just keep going up. That's problematic. Right, on this one, their height was high, on C, the height was high, but then it dropped down to 0, and then it looks like it's just going off forever in that direction. So that's like a super underdog. So that's out. And then if we go to D, D, it starts kind of at this steady state up here, but then it drops lower than the initial starting point. All right, so that could be problematic. Where D could be a possibility, potentially, um, is really almost nowhere because notice how the bottom of this, all right, kind of arcs through. So that would mean that the bottom of the swing was getting higher and higher as we went on in time. So that's out as well. All right, and then the last one, number 5, which everybody wants to pick B for some reason. A child climbs up a slide and then slides down one side. Right, so we'd expect this child then to its speed versus time elapsed. So climb up at a relatively steady pace. All right, then at the top, we might anticipate some situation where the rider maybe stops and positions themselves. Then they go down the slide, and at the very beginning, they go down fast and they keep going down faster and faster and faster to the end where they slow pretty abruptly. All right, that happens, in my opinion, the best in C. All right, so this section is where they're climbing. All right, then they go down to 0 as they stop and position themselves at the top of the slide. Then their speed increases until they get to the bottom where it very quickly decreases. All right, so C would be our best choice there. Well, B does look like a slide. It's not going to be the right choice on this one. All right, so that's the first activity. The next activity asks you to analyze a few things about a graph. So in this graph, we've got on the y-axis, the per capita number of cigarettes smoked per year. And then on the x-axis, we've got the year, and we're going from 1900 to 2012. And we've got some data points along here. So the first question is, what events appear to have contributed to the sharpest increases? All right, so what we kind of noticed in here is it looks like we have a sharper increase there. It looks like we have a sharper increase through this section. Let's see if we've got any other sharper increases. Those are really the big ones when we look at it. You might have a little bit of a sharper increase right there. So at least two of the places where we saw sharper increases were at times when there were conflict and war. So war in this one tended to correspond with an increased consumption of cigarettes. As we look through, as far as sharpest decreases, it looks like we have a pretty sharp decrease through here. All right. It looks like we've got a fairly sharp decrease there. And then it looks like as we go through, right after this sharp increase, right in this section, we had another pretty sharp decrease. We had a sharp decrease there. And then we had another sharp decrease right there. So those, what I saw is I felt like they tended to deal the most with either taxes, so increased cost, or some type of legislation or legal settlement that was associated with cases against the cigarette manufacturers. So war tended to go along with the ups, and tax, as well as medical info, all right, and courts, say that, tended to go along with it down some. Now, when I look for a tipping point on this, there's really kind of two places that I see in this graph as being tipping points. The first place is going to be up here with the Surgeon General's report. That's clearly where we started to drop back off. I probably wouldn't consider that tipping point because what I notice is right here, it looks like we start to get a little bit of an increase again. Where we really saw it drop was when non-smokers started kind of pushing for rights and protections against the secondhand smoke they were experiencing a lot of places. This is where, since that occurred, is where we've really seen a steady decline moving. All right. 2 says, what is the average rate of change in per capita number of cigarettes smoked between 1960 and 2012? So if I go to 1960, right, 1960, it looks like we're roughly right about there. This next one here so we can see it. Right, and then we're going to 2012, which is right about here. All right, so first thing, if I'm looking at average rate of change, I'm looking at this secant line cut through there. The slope of that secant line, slope of the secant, is going to correspond to the average rate of change. So if I give an estimate, these are not going to be perfect. I'm going to say about 4,200. 4,200 was our starting Y value. We're looking at about 1,200. So 1,200 was our value in 2012. And then that's going to be 1960. Excuse me, 1960 to 2000. And if I go ahead and do that subtraction on the top there, I've got 3,000. And on the bottom, I've got 50. All right, now at this point, we could go to a calculator and we could go ahead and compute what this is. All right, this would be the average rate of change and it would be per capita number of cigarettes smoked per year. And then it would be per year. So this is the number per capita per year, and then it would be per year, which is really kind of an interesting unit when we look at it, because they're summing it up as a totally yearly consumption. So it's the number per year, and then that per year rate of change with that. All right, so that was number 2. And number 3 is when is the per capita number of cigarettes smoked decreasing the fastest? What is the rate of change at this point? Right, so this one is where they're trying to push you a little bit from the idea of average rate of change into the idea of instantaneous rate of change. All right, so I'm going to clear my graph a little bit here, get some pictures off this. And it asks me for the place where it is decreasing the fastest. So I'm looking for a steep downturn. And I would say the steepest downturn on this one to me is right about in there. All right, so what I'm going to do if I want to find or estimate this instantaneous rate of change, I'm going to go ahead and I'm going to get this tangent. Now, from a year standpoint, it looks like you're roughly 1983. All right, was when it happened. And it asks for what the rate of change is. Now, when I'm doing a tangent line like this, I'm really going to have to estimate. In this case, I'm going to come over here. Looks like we're about 35 to 3600. Right, so about 3600 for that. And that corresponded with the year 1980. So in my average rate of change equation, I'm going to go ahead and do y over x. And then what I'm going to do is I'm going to pick another point on this tangent line. So I'm going to move to this point right here. And it looks like that is, roughly speaking, 86. So 1986. And it looks like that would correspond over here with roughly 3,000. All right, so put the 3,000 there. If I go ahead and do a subtraction, I get 600 over negative 3. And I'm sorry, I lost a sign down here. That was negative 52. So 600 over negative 3, that's about negative 200. And that would be number of cigarettes per capita per year per year. All right, and that would be the answer for that part of the question. Now, those are estimates. So if you were within a fair range of each of those estimates, I say you're in pretty good shape in this one. Now, the whole basis of this was looking at average rate of change. Most of the questions you're going to see are so we'll look at those here in just a second.